A two-dimensional list is actually a list that keeps list objects in that. So by using this kind of a trick, we can create two-dimensional lists which will look like this in this example. Like we will have rows and the columns, and in each row we will have one specific list actually. And by using these square brackets two times, we can access any item in a particular item. Well, why is this important? Well, we can basically create many structured data in this. Like think about a CSV file. A CSV file has rows and then columns. So we can actually load that data and put it in a two-dimensional list, and then we can process that data. So this is a pretty common way to deal with the structured data. Here you see one example. I had copy pasted to my Python to gain some time, and this will make it more readable because of the colors. So let's look at this code. We first import the random library to just generate some random numbers. And then we define how many rows and columns we will have. And now here is how we can create a two-dimensional list. As you can see, I put one square bracket, and then the red one shows where it ends. So it's actually one list, but in that list, I have three other lists. So one here, the other one is here, and the other one is here. So actually a two-dimensional list is a list that contains more lists in that. And then each list has 4 items. So I have 3 lists, and each list each of these lists has 4 items. And then how can I process this kind of a two-dimensional list? By using nested for loops. So the first for loop is to iterate over the rows. The second one is to iterate over the columns. And then when I say that, okay, values R and C, note that like I put the square brackets and then R. So which means that like let's say that if let me actually run this code. So what I'll get is when I say values R, it gives me actually, if let's say that R is 0, it will give me the first list in my two-dimensional list. So it will give me this. Then I'm saying, okay, from that list, give me this, the one that has the index C. If index C is 0, then it will give me this one. When R is 0, C is 1, I will get this. When R is 0, C is 2, 2, I will get this one, and so on. And when R is 1, I will move to the second list, and so on. So basically, in short, in each cell, I can really access to each cell separately, and then assign values or whatever I want to do with them. I can do it for each cell separately. But what you have to remember is that we need to use this kind of a nested loop to iterate each cells. Do you have any questions so far? All right, then the other important concept is tuples. Tuples are very similar to lists, but what is the difference? In lists, we can change a value of a list, of an item. Like if I have a list, then I can rechange it, I can set its value. But in a tuple, I cannot change it. This is the main difference. And when I'm defining it, I need to use these parentheses instead of square brackets. So let me write one example here. If I have this kind of a tuple, for instance, this is a tuple. So the main difference is that when I try to, I can access it, but if I try to change it, I will get an error. So once I create it, I cannot change it. So that's why it is called immutable. I want you to memorize this term, immutable. It means that its values cannot be changed. But still, we can use many operators that we use for the list. Like we can use the index function, len function, min, max, and we can use the in operator to check if an item is in that tuple or not. We can use this plus or the multiplication operators as we do in the list of objects. But we cannot use those methods that we use with the list, like append, remove, insert, reverse, sort. The reason is that these functions changes the value items in a list. But in a tuple, we cannot do it. That's why we cannot use append, remove, all these functions for the tuple objects. And well, you might say, okay, why do we need tuples? Because it is, well, why do am I limiting myself? Well, first, it is faster if you use a tuple. And the second one is sometimes we really shouldn't change it. Like, let's say that I created a students and their ID numbers. Once I created it, I should not be able to change that. Because there's maybe a software developer mistakenly will try to change it, but he shouldn't normally do that. So if I put it in a tuple, even though they will try to change it, they will not be able to. The program will not allow it. So it makes our data also safe for those cases. And of course, well, you can always convert a list to a tuple and tuple to a list. Like if you have a tuple, then you can convert it to a list object by using this list function. Or if you have a list and you want to convert it to tuple, then you can use this tuple function. Like when you can do it, well, let's say that you have a list, you generated, you added items, all that, and then once you said, okay, my list is finalized, I will not change it anymore, then I can convert it to tuple. Then all my operations will be faster later on, so that my program will be efficient. So I can change the data type by using these functions. And the other one is zipping function. So what is this? Well, let's say that I have more than one list and I want to merge them but not concatenate them. So this is a different part. Let me show you this example. Let's say I had actually written this also in my code, so I will also show it from here. Let me open this part. I need to put one more here. All right. So let's say that we have this list of student names, and now we have their corresponding GPAs, but it's in a different list. So one is names and the other one is GPA. And I want to create, merge these actually, so that I will know that, okay, which student has which grade. So by using this zip function here, which takes these two lists, names and GPA, it will create me a list of pairs, a list of tuples actually. And then when we run this code, this is what we will get. So basically, for each item in this name, it will merge it. It will create a tuple with the corresponding GPA score. So and then when I iterate over this list of tuples, list of pairs, what I will get is, like for student Ali, which is the first item, here his GPA is 3.6, which is the first item in GPA. And Ahmed, which is the second item here, and then his GPA is 2.86. So I can basically merge them, these two lists together, so that, and then it will give me a list of tuples. And does it have to be only a single two lists? No, it doesn't have to be. Well, it can be actually more than that. Let's say that, let's look at this code now. This is a little bit more sophisticated code. Like, again, I have this names and GPAs, but I would like to create one more list, okay? Which is that student is in the dean list or not? Is it selected to the dean list or not, okay? So what does this do? Let's look at this part, and we had seen this in the previous lecture. Let me actually run it and then to understand what it is generating. So when I run this code, what is this is selected? Well, what it is doing is we iterate over the GPA list. For each item in that GPA list, we put this item in the is selected list. So 3.6, is it greater than 3.5? Yes. So then I will put that through here. Then 2.86, is it greater than 3.5? No. Then I will put a false here. 1.9, it's less than it, so it's false. 4.0, it's greater than 3.5, so it is true. So basically, this creates me a list that has 4 items in which we have all these Boolean values. So now, going back to here, my code, now I have 3 lists, and I want to merge them so that I will create a list of tuples so that I will know that the name of the student, their GPA, and if that student is selected is in the dean list or not. So again, I will use this zip function, in which I will put all my lists in that, and then it will create me this Dean list. Then when we iterate over this Dean list, let's see what it will go, what it will produce. So this is the output. So now, again, I have a list of tuples, but now the tuples has 3 items: name, GPA, and also whether that student is selected to Dean list or not. Any questions so far? All right. If I'm going so fast, please let me know, and then I can slow down. Now, the other thing is, now, currently what we have seen is we have seen lists. By using lists, we can create two-dimensional, multi-dimensional data, and then we can even merge them and create this kind of structured data. Where do we use it? We usually use it to data analysis. And when we do an analysis, we probably would like to show it like with a graph, so that it will be more visual and easy to understand. So how can you do it? Well, you can use your Microsoft Excel program or so to generate all these charts. But actually, when you learn this topic, then you might say, okay, I will not use Excel. I will use this later, this library from now on, because this also what happened to me. Once I learned that, okay, I can create charts by writing a code, I stopped using the Excel chart and so on. The reason is that it gives us the full control on what we want to show in a chart. So now we will see this. So one of the ways is that we can use this matplotlib library to generate charts to generate charts from our data. How can we do it? Well, you have to first install it if it is not installed yet. And installing a Python library is very easy. You just need to, if in a Windows system, you just need to say pip install and then the function and then the library name. And then it will automatically fetch the data from internet, go to the correct website, download it, install it, and then you don't need to do anything else. It will download, install everything that you need. If you are in a Mac computer, then you just need to put this one more sudo function. Once it is installed, then you just need to say import matplotlib, so that then we can use its functions to generate our charts. Now let's look at one example. And the first example will be a line chart by using plot function of a matplotlib. And when we are using it, these libraries, we can import it as we said, the import matplotlib and so on. And then usually what we do is we also give a name to our libraries, a variable name, so that then we use that variable name in our code, so that it will make our code actually simpler. Instead of using library name at all time, I will use this PLT, for instance. Actually, now here is this code, but I had already written it in the Python, so I will show it from here. To simplify it, first I will remove this part, then I will put it back again. So again, I'm importing the library, and then I say splt, but this plt is a variable name. Again, you can say any name here, okay? But then when you say any name here, then we should also change these PLTs to any name here, okay? So this is a variable name, but it is common to put PLT for the matplotlib library. And then here is what we are doing. Here is we have a simple data. Of course, in a real application, the data will be probably much more sophisticated, but for simplicity, we have this two-dimensional data actually, x coordinates and the y coordinates. And then I want to plot it. So what I need to just say is plt, which is our variable name, dot plot. Plot draws us a line chart for the given x coordinates that I provided here, and for the y coordinates that is provided here. Then we have to call this show function to display it, otherwise it won't. And then when we run this code, what we will get is, here is the output. Actually, it's shown here. Here is the line chart. But let's look at it if it is correct. The first value is x is 0, y is 0. As you can see, is x is 0, y is 0 here. And the other one is 1 and 3. So x is 1 and y is 3. So it's basically based on the data that I have, I can now generate any plot I would like to have. And again, I said that once you learn it, actually, you will probably continue using this because it gives you the full control on your chart. Like, let's say, okay, I have these zeros and ones. Actually, it represents the budget. So it should show, instead of saying 0, it should say $0 million. If it is 1, it should show $1 million. So what I put here is, by using this ytext library, function, sorry, I said, okay, for these 0, 1, 2, 3, 2, 4, 5, for the y-axis, use these names. And similar for the x-axis, maybe these numbers are actually number of years. Like, it's not 0, it's actually 2016. It is representing 2016 and so on. So I would like to change the number that I see in the x-axis. So then I call this x-ticks. And then when I run this code again, now as you can see that now I could change this part. And well, we can, I would like to make a one copy paste here. Let's say that, okay, I want to also set the limits. Like, it's not from 0 to 1. Maybe I would like to show the x-axis from 1 to 100 or from 10 to 50. When we do it, of course, our plot will look very weird because our numbers are actually less than this. So I have to also change this a little bit. At least we will be able to see it. Okay. It will still look weird, but at least we will be able to see them. I think I need one more space. Yeah. Let me run this code now. Okay, this is the reason that we put the x max 100, so it goes to the 100, and then for the y max it is 50. That's why it goes to the 50. That's why. But if you said, okay, x max should be only 3, y max should be also 3, then if you run it, then we'll get this data. So basically, again, we can change the labels, the whatever value that the limits of our y-axis. Actually, I have one more example that I also copy pasted from this slide, but it is maybe because of the color it's not seen. Let's look at it here. It's just a copy paste of it. Yeah, I have to put these back. And then when I run this code again, oh, this is not pi, sorry. There is a copy paste error. Actually, it is coming from the previous slide, previous lecture. Anyhow, I'll just fix this part. Yeah. So let me run this code again. Now, I can, as I said, change many details. Like, I said that, okay, I want to put these circles here so that the point will be easier to understand. That's why I put this marker is this all sign, okay, a circle. Or I would like to put the title, sales by year, so sales by year is shown. I would like to put a label for my x-axis, so it put this year here. Or, well, I would like to make my data more readable, so that's why I put these grid lines, okay? But of course, if you don't like it, well, you can just change it, remove it, and then run the code again, so it will be removed. And there are much more details that we will not be able to cover because it will probably take one whole lecture, but actually it's not that also important because you can, whenever you need it, you can just check, okay, what matplotlib library provides, and then you can manually change all the details. Like, I want to change the font size, the colors, that should be here. I would like to put one more additional line here to show the data. Whatever you would like to do from a stylistic perspective, you can write a code for that and then show it. So you will have a much more power control on your data. And also, let's say, okay, I don't want line chart. I want to have actually a bar chart only. Then, well, you can just say, okay, this is the bar chart. Of course, when we run a bar chart, some application might not make sense, but anyhow, some of the details there. I can easily change it to a bar chart instead of a line chart. Or maybe you will say, okay, I actually want to have a pie chart. So in a pie chart, I will make a copy paste from the slide. That would be more meaningful. In a pie chart, we don't have axis or y-axis, but let me run it here. Again, I have only one values here, and then I would like to create a pie chart. Again, you can set the title, you can put the numbers, you can make that pie chart fancy by just using this matplotlib libraries, some other functions. But in short, you can create any different chart, like even this box plot charts also, which are much more sophisticated charts. You can all create it, these kind of charts by writing a code, and it gives much more control on your charts. So once you learn it, I think that would be, you wouldn't prefer Excel or so, you would prefer to write a code for your charts. Do you have any questions so far? All right, then let me proceed. Well, in this lecture, what we have seen is now, what we are doing is, we have seen two-dimensional lists. And then we have seen how to represent it. Then, well, each actually is used for data analysis. But for the data analysis, there is one more thing that we keep doing, which is doing linear algebra operations, matrix operations. So, is there anyone who has taken linear algebra course? Not yet. Good. That is fine. You are not, of course, responsible for linear algebra knowledge for this course. In the following slides, we will see some linear algebra operations. I will not go in detail about those operations, okay? If you don't understand it, that is completely fine. You are not asked to do linear algebra operations. But what I will show is how we can use Python to do those operations, because it is extremely needed for many scientific computation. If you are an AI research, if you like to work on AI, actually we frequently use linear algebra operations and matrix operations in training the models and so on. So it is actually pretty common calculation in these areas. So first, when we are dealing with matrices, so what is a matrix? Well, usually you can say that this 2D dimensional numbers. So why is it important? Again, from a computer perspective, like many data, any structured data with numerical values, it's just a matrix actually. It has rows and the columns, and then we would like to do some operations on that. But the challenge when processing with those kind of data is that Python doesn't support matrices. The list does not have any built-in type matrices. So what we can do is we can create a 2D list, which is a list of lists. So when I create a list of lists, then I can simulate a matrix. Okay, I can create a matrix for that one. But still, it doesn't support the matrix operations. What I mean is, well, in a matrix, for instance, let's say that I have all these matrices from A to G with different numbers with different sizes. I would like to find, okay, its dimension. I would like to take one square of it, one column from that one. I would like to do maybe two addition operation of two matrices. I would like to multiply them. I would like to take the inverse of the matrices. Again, you are not responsible how to do these linear algebra operations. But once you learn that, once you need that, Python doesn't also provide these operations for us. This is the one challenge. And just to give you one example, let's say that I want to do the summation of this E matrix plus B matrix, okay? Then, in a matrix operation, what the result should look like is, it's actually pretty easy. I take the first item from E, which is 1. And then I take the first item from B, which is 4. 1 plus 4 is 5, as you can see also here. Then I move to the second one, which is 5. Here the second item. Here is 3. 5 plus 3 is 8. So which is the second item here. So I do this for all the operations, and then I just do this operation. Well, that's pretty simple. But the question, the problem is, Python doesn't support it. Like if I said, okay, here is the matrix, here is the 2D list, here is also a 2D list, and take the summation of them, Python will concatenate it. It will not do this operation. It will do something else. It will not do this matrix operation. And there is one more challenge. Lists in Python are actually very good. Like they are very flexible. In a list, I can put a string, a boolean, a number, an integer, anything in that. I can put it. That brings us very flexibility actually. That's good in terms of coding. But the problem is that from the efficiency perspective, in other languages, they have arrays that we didn't see. But in Java, for instance, we have arrays. What is an array? What is the difference between list and array? In an array, you can put only one type of data. Like you can put either on the integer, either on the string, either on the float. You cannot say, okay, some of them will be integer, some of them will be float. You cannot do it. So there's a restriction. And also there's one more thing, which is it says that data is stored in contiguously in memory. What it means is, in an array, like the first item, now I'm simulating the memory, okay? The first item, let's say here in an array. The index 0 is here. Where do we put the item with the index 1? It's just next to that in the memory. Where is it? The next item is just next to that item in the memory. So the good thing here is that if I know where the first item is, I can easily find the 100th item in that array, because I just know that, okay, if the first item is located here, the 101 is just 100 bytes away or so. So I can easily find that data. But in a list in Python, it is not continuously stored. What it means is, like, the first item is here, let's say. Where's the second item? Well, we'll say, okay, it's over there. I need to go here. Then where's the third item? Well, it's over there. I have to go there. What is the fourth item? It's here, so and so on. It's not continuous. What it means is, when I know, okay, where is the first item is here, okay, where is the 100th item? I don't know immediately. I have to calculate it. I have to find it. So because of this, lists are not efficient. They are not efficient in Python. If I could keep the same data in array, it would be much faster. But in a Python list, it is not. And again, this is important. Why? I had said that, like, we do these matrix operations a lot. For instance, in AI, like, and I want to train the model. And a deep learning model, we do these operations frequently. And in a deep learning model, like, we do this training for a very long time. Like, just to give an example, like, maybe you have heard, like, for these training large language models, they literally use thousands of GPUs and run it for weeks or months to train a version of that model. So again, because of that, efficiency is so important for us. But Python lists are not efficient. So that's efficiency is one problem. And also, again, this is just an example showing that Python lists are not good for matrix operations. Let's say that we have these two lists, A and B. And then if I just say A plus B, Python will concatenate it. Python will give me another list that has this kind of a content in it. It will concatenate those lists. But if I had meant to do a matrix operation, what I would expect is basically add these two numbers, add these two numbers, add these two numbers, and so on. But not a concatenation. Similarly, if I just say 8 times 3, Python will basically take this content and then put it 3 times, as you can see here. Put it 3 times. But in a matrix operation, what the result should be is a list, and its content would be 3, 6, 9, 12, and 15. So it will multiply the numbers in that by 3, not concatenate that list by 3 times. So again, Python does not support matrix operations, and it is slow. Well, what I can do is I need to implement my own function to do those matrix operations. Like I want to do an addition operation. So if I use a plus operator, it concatenates. So I can create one addition function which takes 2 matrices, and then I can create the result matrix, and then I can go over a for loop. I can do this addition operation, and then I can return it. So I can implement the matrix addition operator as a function, and then I can use it in my code to do the same operation. So all of these things that I mentioned here, like from, let me go back a little bit. Yeah, from this slide, working with arrays in Python, up to here was actually just a motivation for why we should use this library. So just for you to shortly, Python lists are not suitable for matrix operations. They are slow, and it doesn't provide us functions that will do those matrix operations, so we have to implement them. Because of this, we use this NumPy library, numerical Python library. It's very common. If you check any Python code related to data science, data analysis, machine learning, and so on, probably you will see this NumPy library that it's being used in some place. And why is this case? Well, it's a very very popular in scientific computation. It basically provides us a multi-dimensional array objects in which, and it provides the functions. Though it also provides those matrix operations, the operations on those functions, so that we can it will not concatenate, but it will do the matrix operation and so on. So it provides these functions, and it will use an arrays, homogeneous and continuous, which means that it will be faster. So by using this NumPy library, it will be much faster, and it already provides many operations that we would like to do with those matrices. So that's why we use this NumPy library. And for the array, NumPy's array, we use this term ND array, NumPy's array. Okay. And it provides us many attributes for this array that we can use in our calculations, like its dimension, its shape, its size, its type, and so on. And how can we use this library? Once you install it, you just need to say import NumPy, and then you can use it. Or you can also give a variable name to it, like by using this as keyword and then the MP. So import NumPy as MP, but then by using this MP variable name, you will say MP dot whatever function that you want to use, its name, and so on. Of course, this MP, again, it can change. It's just a variable name, but usually people give this MP name for that one. And here is one example. How many minutes I have? Let me check. Okay, good. I have 10 minutes and 5 slides. Good. By using this MP library, then I call this array function. It creates me a NumPy array, and I give it a list. So basically, it converts this list, Python list, to a NumPy array, so that I can start these kind of operations. Or if I would like to create a 2D array, then again I need to give here a 2D list. Then it will create me a 2D NumPy array by using this array function. Here is one example. Let me go over that. We import the library, and then we create one numpy library, numpy array. Sorry, by using this array function. It is a 2D array, and each one we have 3 items. When we print this, it will give us this output: 1, 2, 3, 4, 5, 6. This matrix. We can also define the data type in numpy array, like it's homogeneous. I cannot put different data types. In the first one, it is integer. But if I want to put a float, then I define it as a float here. And then when I print it, it will put these dots, as you can see. It represents that those are float numbers, not an integer numbers. And then if I print the shape of the first array, it says it's a tuple 2 by 3. So we have 2 rows and 3 columns. And its data type is int32. What is int32? So it's an integer that we use 32 bits to represent. I will talk about it later on in the following slide. And what about the other one? Well, it's a one-dimensional array, so it has only 3 items. That's why we have this. And the data type is float because we said that it should be float here. So we can identify the data type. And also there are some other functions. To create an array, we had used this array function, or array, or we can use arrange function, which is basically creates an array similar to the range function that we use in for loops. Or ones are arrays, or zeros. Those basically creates an array with a certain type that we define and initialize all the values with ones if we use this ones function, or initialize it with zeros if we use this zeros function. So it's just to initialize and create an array. And here are some data types that we can define, like integer 8, 16, 32. So what is the difference, like 8, 16, 32, 64? Well, it means that how many bits I want to spend in my memory to represent an integer. If it is integer 8, it means that I can spend 8 bits to represent one number. So, or if I say int 16, then it is 16 bits to represent it. What is the difference? Well, I have a limited memory. So, and if I'm dealing with, in a data science, in a machine learning, we deal with large data. So I need to be careful about my memory space. That's one thing. And also, but I also need to be careful about it. Like if I use 8 bits, what is the largest number I can generate? It is 2 to the power 8, which is 256. If I know that all my data is less than 256, then I can use unsigned integer 8. I will come to this, what is int and uint difference, so that I will use my memory much efficiently so I can process larger data. But if I know that, okay, my data is greater than 256, then I shouldn't use it. Then I should use whatever I need to, whatever is good for my data. And here you also see int and uint. It means signed or unsigned. What it means is I have 8 bits, okay, and I have to represent the data. Negative numbers and the positive numbers. So 1 bit is used to represent whether the data is negative or positive, and then I have remaining 7 bits to represent the rest. So if I'm for an int 8, I will use 1 bit to represent whether it is minus or not, and then for the 7 bits for the positive one. So its ranges goes from minus 128 to positive to 128. But for the uint, it's unsigned, so there's no negative numbers. So I use also that 1 bit to represent a larger number so that I can go from 0 to 256. So based on my data, so this become a little bit technical, I'm aware of it, but what I want you to memorize is that you can define how many bits you want to spend, and based on these numbers, of course, in your memory. It is important if you are dealing with a large data, because your data might be easily filled and then your program will crash because of this. uh, and in a numpy int, so we can also define what's the data type that we would like to. This is all you might need to know for this level. And for this, here is one more example. Again, we create an array, a 2D array, and then we print it. It will print this output. And then we can, again, ndim will give me number of dimensions, so it's a 2-dimension array, so it will print 2. And then we can print, by using this type function, this is a built-in function, it returns the data type. So the ndim gives us 2, which is an integer value. That's why it gives us this integer. Shape is how many rows and the columns we have. So we have 2 rows and 4 columns, so it returns us this 2 and 4 pair. And then I can also, what is its type? Its type is tuple. This is a tuple. And then I can also access, okay, how many rows I have. Well, from this tuple, if I reach the first item by using the square bracket 0, it will give me the number of rows. And the other one will give me the number of columns. And by using the zeros function, if I give 10, it will create me an array that contains all zeros, 10 zeros. If I say 3 by 6, then it will create me a 3 by 6 matrix. Each values are 0. But if I use this once function, then it will again initialize it, but all the values will be 1. And I have 3 minutes, so I'll be a little bit fast. Well, I'm looking at what is not explained yet. So this range function, again, similar to the range function that we use in the for loop. So it generates numbers from 0 to 1.5 with this incremental step. And then based on that, it generates a data. And the good thing here is I have this one list, and then I have the second list. Then I can do this subtract operation, like a matrix operation. Now, it's not anymore concatenation. It's not, or I can do this, when I do this multiplication, it will do element-wise multiplication. What it means is, like I have this 2 and 1, 2, 3, and 0, 0.5, and 1. When I say I need to multiply it, it will give me 1 times 0, it is 0. 2 times 0.5, it is 1. 3 times 1, it's 3. So it will element-wise operation. If I do the subtraction, again, it will subtract 1 minus 0, it is 1. 2 minus 0.5, it is 1.5. So for each element, I can do all these operations. And also, again, going back to our slide again, for the matrix operations, I want to do this matrix multiplication, and so what I can do is, first I need to convert, I have to represent it as a numpy array, as can be seen here, that by using this array function, we can represent all of them. And then the good thing here is that then, if I use this matmul function, which means that to do matrix multiplication operation, it will do matrix multiplication. It will not do what the I don't need to implement it. I can just use those functions to do these matrix operations. It's 1049, okay. And it also provides some other parts, like you can take the inverse and so on, but I will not go in detail. I'm aware that you didn't take any linear algebra course yet, so you don't need to know how to do a matrix multiplication, addition, or so. But in short, what you have to know is that by using this numpy libraries, you can do all these operations easily. Even though you don't know how to do it, numpy will do those operations. And it is pretty common in scientific computation and so on. That's it. This is our last slide for this chapter, and it's 10:50, so I should stop here.